Hello, everyone. So today is our second day on key features. Last time we learned domain range, x-intercept, y-intercept, and symmetry. And you found during your practice that sometimes you didn't always need your graph to solve some of these, like in y-intercept and x-intercept, right? You could plug in to the variable 0, whichever one it is, and then solve for the other one. So that's pretty nice. So today what we're going to do is go over, let me cover this up. Sorry, everyone. We are going to go over increasing, decreasing, constant, and relative max and min. So let me get this. There we go. Okay, so increasing. Increasing is where the graph pretty much goes up, right? But we're going to be more specific because it depends on the way you look at the graph. So what you want to do is as you look at the graph and as the graph moves to the right, so like you read left to right, as it moves to the right, the y values get larger. So that's what I meant by it goes up, right? For decreasing, same thing, but except the y values get smaller. So as the graph moves right, the y values get smaller. Constant is as the graph moves right, the y values stay the same. Okay, so it's just horizontal like that. Okay, of course, if as you're writing these definitions, I am going too fast, pause the video so you can write these down. So we have increasing, decreasing, and constant. Now, relative max and min. I want to make this clear that this is different from absolute max or min, okay? Two different things. Absolute max and min, you'll go over more in higher mathematics, okay? This year, we're just going to focus on relative max or min. So what is relative max? Well, a relative max is a point on the graph where it goes from increasing to decreasing. So there's a change. Again, it's a coordinate pair. It's a point. So you need to write down an x comma y. Now, when it comes to absolute max, that's the highest y value, the largest y value the graph goes through. And in that case, you only need the y value. But since we're doing relative, we need the coordinate pair, and it has to be going from increasing to decreasing. That goes the same for relative min, but of course, it's a change of decreasing to increasing, right? So it's that coordinate pair. Absolute minimum would be the lowest y value. There's no change in there. Now, could the relative min be the absolute min? Yes, but we're going to stick with relative. I might point it out if we have an absolute, but we're not going to write it down today. Okay, so let's go to our graphs that we did last time, and now we're going to fill out the increasing, decreasing, constant, and relative max and min. So on this graph here, when we look at increasing, decreasing, and constant, what I like to do is I like to start at the very left of the graph and kind of trace the way my finger would go for it. As you can see, what's happening the whole time? I'm going up, right? My y values are increasing the whole time. So that means, is it decreasing at all? No. So I'm just going to put none. Now increasing. It's increasing the whole time, but let's look at the domain of this graph. Where does it start? It starts off at -4. Here's the other thing. Increasing, decreasing, constant, when you make your intervals, are x values. So let's actually go back to our definition and write that down so you guys can always refer back to that. Okay, so for increasing, decreasing, and constant, we write intervals with x values. Okay, intervals with x values. So that's why when we go back to this example here, and it is increasing the whole time, but my left side starts at the x value of -4. And it's filled in, so we're going to have a bracket. And it continues to increase, and there's an arrow that means it increases to infinity. Okay, now it increases to infinity because we're going right to infinity. Okay, constant. Well, we went over that. The whole thing was increasing, so we don't have any constant. Now, relative max or min has a change of increasing to decreasing or decreasing to increasing. So there are none. I do want to point out, because many people will make this mistake and call this a min. It's a min, but it's not a relative min. It's an absolute min, because we're not changing. We're just going increasing, correct? So that means it's not a relative, but it is the lowest point on the graph. So that would be an absolute min. Again, we're not going to write that down this year. You'll go through it in following years. Example 3. Okay, first thing I'm going to do is trace my steps with my finger. So I'm going to start at the left side. There's an arrow there. Okay, and what happens? I'm going down and then I'm going up. Now, some of you might remember your tracing, but if you don't, sometimes I like drawing myself arrows to remind myself that it's changing. Okay, so let's do it in order, unlike I did the other one, which was increasing. So I'm looking at my increasing and I'm looking at my up arrows. Okay, now remember, it's the x values. So where does it change? It changes right here. Okay, so what is that x value? It is 3. And then it goes and it keeps going up all the way to the right. So that means infinity. Now, parentheses are always around infinity. Here's a different thing that happened last time. Remember last time we started at the coordinate, right? So it was a bracket. Right here at 3, can we really say that it's with increasing or decreasing? No, because it's neither, we always put a parenthesis. Okay, so 98% of the time, you will use increasing, decreasing, and constant with parentheses. If it starts or ends, no arrows, right? Then you have to determine if it's a bracket or not. Okay, decreasing. Now, tricky part, right? This is our decreasing right here. Even though this arrow is going up on the left side, we're looking at the left. So the x value is to the left. Well, where would that arrow be pointing? To the left. It would be pointing to negative infinity. Okay. And then it goes down, and where do we change? We change right here at the value of x equals 3. It's parenthesis again because we can't tell if it's increasing or decreasing. So let's keep in mind that when we go left to right, you talk about negative infinity to infinity. Now you see how I just did this in order from increasing and then decreasing just because the chart told me to do so. You don't have to do that. You could have said, you know what, I'm going to start at negative infinity and I'm decreasing. So you could have started with the decreasing. And I'll show you that on the next one because it's kind of confusing. Now constant, did we go straight at all or horizontal at all? No, we didn't. So there's none. Okay, relative min. Remember, relative min is a change of decreasing to increasing. Do we have a change of decreasing to increasing? Yes, we do. Right here it changes. Now remember, we're writing that coordinate pair, x comma y. So what's the x? 3, and what's the y? 1. So we have a relative min at 3, 1. Relative max. Do we have a change of increasing to decreasing? No, we do not. So none. All right, let's go to our next graph. Okay, this is the crazy one. So first of all, I'm going to use my fingers to trace it, use my verbal, my words, right, for decreasing, increasing constant, my arrows. And then I'm going to show you that trick about going in order from left to right, okay? So I start at the left, and which way is my finger pointing? It's going down, so it's decreasing. And then it turns back up, so it's increasing. And then it goes horizontal, so that's constant, right? I might put a C just to remind myself. Now here it goes constant. And then what is my finger doing? It's going up to increasing. Then it's going down to decreasing, going back up to increasing. And then what is it doing here? It's going constant. So see how I did that? If you don't like the arrows, my other thing you could do is actually write D and I. Okay, those are my little tricks. Now, I'm going to show you this time that we're going to actually put the interval in order from left to right in the correct spot. Okay, so we're not just doing all the increasing, all the decreasing, all the constant. Okay, this way you're going in order and you know you're not forgetting anything. So where do we always start? At the left side. That is an arrow. So we're going to start at negative infinity. Now, as you can see, this part is decreasing. So I'm going to go to the decreasing part and start with negative infinity. Then I see that I stop decreasing right here. But what value do I use? I use the X value. So that's 1, 2, 3, 4, 5. So -5. Okay. Now I'm going to go in order, right? So I'm going to start back up at -5. And as you can see, I'm increasing. So let me go to my increasing value here. I started at -5. And where do I go to? I go to right here. What's the X value? -3. I'm going to start at -3. Which way do I go? I go constant. So let me go to my constant. I start at -3 and go to -1 right here. Now I go back to increasing, right? Now I start at -1. So let me go back to increasing here. Now in your homework, it might make you put the U down, the union, okay, to divide those intervals up, or it might make you do a comma. So be careful on that. So where did we start again? We started at -1 and it increases all the way up here, right? What's that X value? That X value is 1. Then at 1, we start decreasing. So let me go over to decrease. Where are we starting again? We're starting at X equals 1. And we go all the way here. What's that X value? 1, 2, 3, 4. Okay. We start at 4 and we go increasing again. So union 4, 2, right here is, let's see, 4, 1, 2, 3, 4, 5. So 5. And then we go constant. So let me go to my constant area. I go 5, 2, and that arrow tells me it continues straight across all the way right, and all the way right is infinity. Okay, so that's another way you could have done it. So again, you get to choose which way works for you better. Do you want to just take all your decreasing and write them down? You want to take all your increasing, write them down? Excuse me, guys. Or do you want to do it in order like I did? Okay. Oh, now this is going to be tricky, right? Because it seems like we have a lot of maxes and mins. So let's look at our changes of increasing to decreasing. Now remember, constant's not involved there. So there's a change of increase to decrease. There's a change of increase to decrease. And there is the change of increase to decrease. Okay, so relative min. Relative min is our decrease to increase. So we have a decrease to increase right here. What coordinate pair is that? 1, 2, 3, 4, 5. So we have 5, comma, and it looks like it's at -2. Remember, coordinate pair. Then we have another relative min. We have a change of decrease to increase, decreasing to increasing right here. So we have another coordinate pair, and that's at 4. Let's see, 1, 2, 3, 4, -4. Our relative max was right here, the change of increase to decrease. So that's at 1, 4. We'll just call that 1, 4. I know it looks a little bit lower, but we're gonna just make it nice and easy for us, okay? Awesome, that was a big one. That's when you really know your stuff. Okay, so the great thing is we did transformations to have these graphs already, so we don't have to worry about graphing them. Let's trace our graph. So start at the left, as you can see, it's an arrow. So we go up and we go down. So again, it's increase, decrease. Okay, so remember, we always start when there's an arrow, we always say we start at -infinity. So -infinity and we go up, so that's increasing. So -infinity to where do we stop? Right here, but what's that value? The x value is 2. And then we start to decrease at that x value, which is 2. And we decrease. Now look, this is where people make a mistake, right? They want to say they decrease because the arrow is pointing down. We think -infinity, but we have to think of the x values. The x value is this way, means it goes right. So what value is all the way right? Infinity. So be careful with those mistakes. Did we say constant at all? No. Now, if you look at our graph, it goes increasing to decreasing, which would be a relative maximum. So there's no min. And look at that max, that relative max. What's that coordinate at? It's at 2, 3. And we're done. All right, is this our last one? Yep, it's our last example here. Okay, I like this example because there's a tricky part in it that a lot of people make a mistake on. Okay, so again, let's trace it. So we're going decrease to increase, right? Going down to up. So decrease to increase. Okay. So again, when we start all the way left, what x value are we starting at? We're starting at -infinity. So we're starting with decrease. So I'm going to put -infinity down. Now, here's the trick part. A lot of us will go back and trace and we'll say, oh, it decreases to here, right? Most of us will put down -4, but -4 is the y value. We need the x value. What is the x value? Right here. It's at 0. And this is where a lot of people make a mistake. That means when we start to increase here, we start at, again, what's the x value? 0. Okay. And if we continue all the way right, would be infinity. So here's a clue with this, guys. Since our graph is continuous, meaning there's no jumps, there's no holes, it's just straight, my finger does not lift, right? Oh, sorry, guys. Hold on 1 second. Yes, I need to put a thumbtack in the motion detector. Okay, so back to my thought here. Because it's continuous, like I said, I didn't lift my finger at all. None of these values, when it comes to negative infinity, should repeat. Only the point of where it changes should repeat. And all of them should connect. In this graph, we said nothing about constant, so none. And here, if we go back to our graph, we have a decrease to increase. So decrease to increase is a min, so I'm going to say none for a max. And let's look at our coordinate pair for a relative min. This coordinate pair is at 0, -4. All right, so you are ready to do some practice and see what these notes have given you. The other thing I want you to keep in mind is that this practice work for today will also include the practice work from last class, just so we keep in mind that key features is everything. It's just not in parts. So you are going to have some domain and range, x-intercepts, y-intercepts, and symmetry questions in today's practice work. All right, if you need help, come and ask me.